All right, thank you for watching the review for the test tomorrow. I hope you can hear this okay. I do not have a microphone that works, so I'm going to have to step away at points. I'm talking into the computer. And, well, just watch the board, and hopefully that will help. And I will come back to the computer standing as closely as I can when I read the problems. The first problem I want to work for you is a basic population problem, because it's similar to one that will be on the test tomorrow. Let's say we live in Frankfort, Kentucky, where the population is 50,000 people. And the population in Frankfurt's growing at a rate of 2% per year. We'd like to know, when will the population be 100,000 people? What we can do is first set up the equation in exponential form, and it will look like this. 50,000 is our starting point, so we put that there. Our rate of growth, 2% is the same as 0.02, but I've got to add that to 1 because it's growing by 2%. So it's 1 plus 2%, or 1.02, raise that to the x. That is our equation that would show us the population of Frankfurt anytime over the next X years. But we know what we want our population to be, so I can replace the f of x with 100,000. So the question is, what value of x makes this statement true? We want to work backwards and find the value of x that gives us 100,000. Well, our first step is going to be to divide both sides by 50,000. And when we do that, we get 2 on the left, and we're left with 1.02 to the x power on the right. Now, this is where the logs come in. We're going to take the logarithm of both sides. Log of 2 and the log of 1.02 to the x power. Note that we have an exponent. Exponents can be brought in front of the equation to rewrite this as x times the log of 1.02. And that, of course, is still equal to the log of 2. Continuing with our algebraic approach, x is equal then to the log of 2 divided by the log of 1.02. I now have to use the calculator to find the answer. So clear this out for a second. And I'm going to punch in log of 2. Make sure to close the parentheses, divided by log of 1.02. And it turns out that Frankfurt will grow to be 100,000 people in 35 years if the rate of growth continues to be 2%. So that's the first type of problem that's on there. Work some more if you need to. Maybe work the problem to say, when would the population grow to be 150,000? I think you'll find the answer to be somewhere in the neighborhood of 45 to 50 years. And just see what answers you get when you try different problems. If you've got any question on how to work a population growth question, it will be just like this. Please see me tomorrow morning. I will be here at 7:30 in the morning. Okay, next type of problems involve the basic principles of logarithms. For example, can the log of 4 plus the log of 6 be simplified to a single logarithm? In other words, can I take and write it as the log of a single number? And the answer is yes, you can. You multiply 4 times 6, and you get 24. If you'd like to verify that on the calculator, we simply punch in log 4 plus log 6, get our answer. Let's make sure that's the same as log 24. And yes, it is. Now, be careful. What you cannot do is this. You cannot take the log of 4 and multiply it times the log of 6. That doesn't work. You add exponents, and it works. Next kind of problem that you might have. How many different ways can you rewrite the following? What? I can write it as a subtraction of 2 logs. this is the same as the log of 2 minus the log of x. I could write it as this way. I could pull x up to the numerator. Be careful though. What you cannot do is rewrite this as negative log of 2x. This does not work. But either of those first two are perfectly acceptable solutions and they work. We could try it with numbers if you want to verify that. Let's assume x equals 5. And on your calculator, you can find the log of 2 divided by 5. You could also say, what is the log of 2 minus the log of 5? Oops, sorry, I didn't use my parentheses. What is the log of 2 minus the log of 5? See, you get the same answer, negative 0.397. For that matter, I could say, what is the log of 2 times 5 raised to the negative first power? Same answer again, but here's what's not true. That is not the same as the negative of the log of 10, 2 times 5, because you can see that's obviously negative 1, not the same answer. Okay? So some equivalencies that use some of the basic rules of logarithms we've talked about. Even easier problems, at least I hope they're easier for you. If you have to find some solutions to logarithms, for example, if I ask you what is the log of 100, hopefully you recognize that it's the common log, so it's really asking 10 to what power equals 100, and the answer is 2. 10 squared is 100, so the log of 100 is 2. Natural logs are not that much more difficult. If I have the log of e cubed, that's just simply equal to 3, because that's the same as 3 times the log of e, and the log of e, natural log of e, is 1. So you could even do that on your calculator if you needed to. Rewriting in change of base and that sort of thing, that problem, there'll be 1 or 2 of those that you'll need to do. If you need to find the log of 7 base 2, you could rewrite this as the log of 7 divided by the log of 2, and you get your answer. .8. And think about it for a second, that makes sense, because 2 cubed is 8, 2 squared is 4, so it makes sense that 2 to the 2.8, a number between 2 and 3, should yield a number between 4 and 8, and it does. It's 7. 2.8 closer to 3, so you'd expect a number that's closer to 8. So that works. Rewriting in this format, maybe you want to know the log of what number base 4 equals 3. Rewrite it in exponential form. 4 cubed equals x. Logs are exponents. 4 to the third power is 64. That would be x. And you can verify that using change of base. The log of 64 base 4 is the same as the log of 64 divided by the log of 4. And if we try that on our calculator, we better get 3, or something's not right. So let's clear it out. Log 64 divided by log, not 3, 4, and we do indeed get 3. So those are just some sample problems of kind of what's on the test of rewriting logs, understanding the base, and how you can change the base. Let's see if there's anything else on this test as I look through it that we have not covered. Make sure you've gone through that all about logarithms sheet that I gave you. Oh, here's a problem. This is kind of getting to the understanding of what logarithms are all about. So let's say we've got an earthquake. Unfortunately, 2 earthquakes. Earthquake number 1 measures 8.2 on the Richter scale. Somewhere else on the earth, there's earthquake. Earthquake number 2 records at 6.2 on the Richter scales. I'd like to know how much more powerful 8.2 is to 6.2 on the Richter scale. And you may be tempted to say, oh, it's 2 times more powerful because 8.2 minus 6.2 is 2. Or maybe you'd say 8.2 divided by 6.2 times more powerful. But remember, earthquakes are logarithms. They're exponents. So the log of this first earthquake, we'll call this x, and this one y. The log of x minus the log of y turns out to be 2.0. Because the log of x is 8.2, the log of y is 6.2. Their exponents are 2 apart. So when I want to know what is x divided by y, it turns out that's the exponent 2. The answer is 10 squared. An 8.2 Richter or earthquake on the Richter scale is not 2 times more powerful, but 100 times more powerful than a 6.2 earthquake. Likewise, if it was 9.2, it'd be 1,000 times more powerful. If it was an enormous earthquake, 10.2, it would be 10,000 times more powerful. So it's going up by a factor of 10 every time the number goes up 1, and that's because we're using logarithms. Logarithms are exponents. Our base is 10, so 10 times more powerful. Here's what I recommend for the test. Please go over your first quiz that you took. Please go over the practice quiz that I gave you last week, and definitely review the problems on the finance. There will be a finance question on there as well. Excuse me. You should do well on this if you've reviewed that. And I'm going to stop this recording. Send me email tonight if you have any questions, and definitely come in tomorrow morning if you have any questions. Thanks for watching.